Hello and welcome to lesson 23.1 in the Python tutorial series. Today we're going to be looking at a really important programming concept, and that is the list data type. Now, so far we've looked at a bunch of different data types. We have integers, we have floats, there's been strings. Lists are among the most powerful of all the data types, and that's because a list pretty much does exactly what you would expect. It keeps a list of different data. So it can be a list of strings, a list of integers, a list of floats, or a list of any combination of those. This can become a really important programming tool when you're trying to keep things like an inventory straight. I mean, you could have 10 different variables to represent 10 different inventory items, but it's much easier to have a single variable inventory that has a list of all the objects that are in the player's inventory. So this programming concept really gets into some powerful programming ability. You'll be able to make some pretty neat programs once you master lists. Of course, it's not going to come easy for everybody. This starts to get into some more abstract and conceptual programming, a lot more so than we've gotten into so far. So just stick with it and you will definitely pick up on it, and you will find it's one of the most useful tools in a programmer's toolbox. So let's go ahead and get started with lesson 23.1 on the list variable type. So here we are in a new programming window. I have my Python shell open, and the Python shell is probably where we'll spend a majority of this lesson here. We might make our way over to the programming window, but first we need to see what a list looks like. In its most basic form, a list is simply a bunch of variables in square brackets. So let's say I had the number 10, 20, and 30. I use the square brackets to tell Python that this is a list data type. I separate all the different values in my list with commas. And you can see that's a valid Python data type there. This is a list with 10, 20, and 30 in it. A list can also contain strings. So I can say Arizona, Steve, program, and computer. This would be a 4-element list with 4 strings. And again, I've noted that I want this to be a list by putting these square brackets around it. Of course, when I hit enter, it's going to return my list with 4 items in it. So that's the first thing to keep in mind about lists. You're going to use brackets to denote to Python that you want to use a list. Now, a list can be of any length. A list can be just a single number. It can be 2 numbers. It can be a float, 3.14, 5.67, 10.1. So it can be of any length, and it can also be of no length at all. This right here is what's known as an empty list. It's a list with nothing in it. That may not seem all that important, but having a list with nothing in it can be super important as well. Again, imagine you have an inventory and you've used everything in your inventory, you've got nothing left. An empty list can still represent important data. The fact that it's empty might be of importance by itself. This can go up to thousands and thousands of items if you want it to. A list can also have different data types in it. I can have a list with a float, an integer, and a string. That is perfectly acceptable. Now, normal variables can only have one data type. You can't have an integer and a string as the same variable or as the same data type. But within a list, every element of a list, and these are called elements, can be of a different data type as long as it's a valid Python data type. So let's start working with list variables. I'm going to create a variable called grades. And this would hypothetically represent a student who was doing assignments in my class. So this is going to be a series of numbers to represent their score. And the first assignment that they turn in, they get an 80%. The second assignment, they get a 70%. And on the third, they get a 90%. I close those in brackets, and you can see that I get that gray highlight. That lets me know that Python recognizes the start and end of my list. And because it's in brackets, that's a valid list data type. When I access grades now, grades is equal to the list of 80, 70, and 90. Some of the functions that we used very early on in this programming series can be used on lists. Do you remember the min function? The min function returned the smallest value in a list of arguments. If I say min grades, it will return the smallest integer, or the smallest number, in my list variable. Max also works, so I can say max grades, and that will return 90. Now, if we were going to go forward and make an actual, say, gradebook software using this concept, something like min grades becomes really important if you were going to tell the students that they would get an average of all their assignments, but they could drop their lowest test scores. Something like min grades will return what their lowest test score is very quickly. We also have a sum function. Let's see that turns purple as well. I can take the sum of grades and get 240. Essentially take all those numbers and add them up. Now, of course, the sum function won't work if you have strings. If you have strings in there, you're going to get an error. So if I said, let's see, list, or we'll call this my list. So if I create a hypothetical my list here and I put the number 1, 3.14, and Arizona in there, that is a valid list. But if I try and sum my list, I'm going to get an error, unsupported operand type plus float and string. Because it's trying to add a string to our number, it's going to give you an error. Also, if I use min on my list, for example, I'm going to get the same type of error. It's not that min doesn't work. It's that I'm trying to mix strings and integers and floats together. So in order for min, max, and sum to work, your list has to be of a consistent data type, either all strings or all numbers. So if we go back to grades, so let's pull up grades here. Grades is equal to the list of 80, 70, and 90. This is only useful if I can access individual elements of the list. Sometimes I might only want to access one grade or another, not all three at the same time. This is where index notation comes in. When we did string index notation, we started counting from 0 and went up to the end of the string. And so a string like Arizona at index location 2 was an I, because this I right here was in index location 2 of the string. Lists work real similar. Grades at index location 0 is the number 80. In a list data type, every element has its own index location. If I accessed grades at index location 1, I'd get 70. And if I had grades at index location 2, I would get 90. Let's pull up my list for a second. And we can see that my list, I have 1, 3.14 in Arizona. My list at index location 2 is the entire word Arizona. So strings got broken down to individual characters. List, when you use the index location of a list, you're breaking the list down into individual elements. So my list at index location 1 is going to return the entire value 3.14. A common error that you see with lists will be something like if you did grades at index location 3. Grades doesn't have an index location 3. You're going to get an index error. List index is out of range. If you ever see an out of range error, that means the index location of the list you're calling is too high, and there's no element at that given index. You'll probably see that error an awful lot. It is a very common mistake when you start working with lists a lot. So keep in mind, whenever you see index out of range, normally that means that your index is one too high. It could be that you didn't count from 0, or some of the other functions didn't return a number that you thought they would, but you'll probably want to get used to debugging this index out of range error. Slicing notation also works on these lists. So if I said grades from index location 1, or let's go index location 0 to index location 2, I'm getting 80 and 70. Remember that with slicing notation, the second number is not inclusive. So I'm getting index location 0 and 1, not including 2. So I'm getting 80 and 70. But by this token, 1 to 3 will give me a valid response because we're looking at index locations 1 and 2 here. We're not actually looking at index location 3. However, if I were to do index locations 1 through 4, you'll notice that I'm not getting an error. When you're using slicing notation, you're not going to see that out of index error. Oops, let's try grades 1 to 100. This index out of range error only occurs when you're calling with a single index. With slicing, you're not going to see that error. We can also check to see if numbers are in grades. So if I wanted to do a conditional check, 70 in grades, I'm going to get a true. When I ask, is 70 in grades, it will look at each element of the list and return if one of the elements in the list is equal to my argument. So, is 80 in grades? That's true. Is 75 in grades? That's false. Using the in command paired with an if-else loop or an if-else statement can also be an important programming technique. I might want to know if my user has arrows in their quiver. So if I have a variable quiver that keeps a list of arrows that the user has, I can check to see if there's an arrow in the quiver and get a return value true or false, and that can impact how my game runs. Another function that you'll use quite often with lists is the length function, len. Now when we use that with strings, such as len of Arizona, we got a number, the number that was returned was how many characters were in that string. The length of a list works really similar. So let's do length of grades. You can see I'm returning the number 3. The len function, when used with a list variable type, will return how many elements are in that list. So I think my list would also be 3. If I were to create a new variable and call it empty list, it's currently equal to nothing. I can check the len of empty list, and I get a length of 0. That's another way that you can really check to see if somebody's inventory is empty, is you can do a len on the list variable that represents their inventory, and if it returns 0, you know the inventory is completely empty at that time. Okay, so we're going to break the program right here. I ended up rendering this video and I saw it was just entirely too long, so I want to split it into 2 videos, so this seems like a good stopping point right here. So this is going to end lesson 23.1 on the list variables. Now we're not going to have a challenge program for lesson 23.1, but you'll see that in the next video, which is going to be part 2 of this video right here, and we'll just kick it off right where we left off. So if you have any questions about anything you saw in this video, something didn't make sense, or there's something that I can explain a little bit better, please leave those in the comments and I'll certainly help you out any way that I can. And the most important thing is making sure that everybody understands what's going on and why this stuff works. So anything I can do to help you become a better programmer, leave them in the comments and we'll get you working. Thank you so much for watching and supporting the Python tutorial series, and have a great day.